welcome to the third day of your Unit 1 Operations with Polynomials working with inverses. Today we will be graphing. You're going to have to bear with me a bit, guys. It is a bit of a longer video, I think, but I think it will be worth it, so I'm going to take my time. Here's your warm-up. Pause now. Pause now if you'd like to do it on your own. Okay, so finding the inverse of f of x equals square root x minus 2 plus 3. First, we're going to change it to y equals root x minus 2 plus 3. First step I need to do is switch my x with my y. Remember, this is because those are opposites of each other. Now solving for y, I see that my plus 3 is hanging out the end, so I'm going to subtract the 3 from both sides. X minus 3 equals the square root of y minus 2. Okay, I can't add that 2 yet because I have to deal with my square root. The opposite of square root is squaring. So if I square one side, square all of the other. So I end up with x minus 3 squared equals, and remember these canceled, y minus 2. So that last thing I need to do is move that minus 2 with some addition. Now, can those combine? No, one's inside parentheses, so they're going to stay apart. So my official answer is my inverse is equal to x minus 3 squared plus 2. And you can see all those opposite actions happening. Minus 2's and the plus 2's, plus 3 and the minus 3, and of course square roots and squaring. Okay. Remembering our yesterday's work, determining if the two functions are inverses, we do this with a composition. Again, it doesn't matter the order, I just tend to do whichever one was first. Out of pure laziness, really. Alright, so that means my f is on the outside. Got negative 2 blank plus 5. Alright, inside my blank I put my g, x minus 5 over 2. And then I will carefully demonstrate the canceling. Now this one's a little tricky because of the negative sign, okay? A little tricky there. Now if you'd done it the other way, it might be a little easier, but we're going to go with the tricky way just to show you, all right? So one of the difficulties is when you're looking at this, does the negative 2 really cancel the 2? The negative's going to stay, but the 2's are going to go, all right? So goodbye 2's, okay? So that leaves me my negative parentheses x minus 5, okay, plus 5. I think I'm having an issue. Ooh, this is tricky. All right, so order of operations dictates that I distribute, okay, so negative x plus 5 plus 5. Does something cancel out? No. I get negative x plus 10. Did anything cancel out there? No canceling. They are not inverses. And I thought they were going to be because I forgot my own paper. All right, so they're not inverses, okay? Because we didn't cancel out to plain x. So keep that in the back of your mind. They have to cancel out completely. On to notes. Now, if you'd like, this is also linked onto the Google Classroom. If you do not remember much about graphing, this is a good video to watch because we will be doing some graphing today. We're going to do a brief review of graphing. Now, if you'll check in your packet I gave you, okay, there is a graphing review. It's the top sheet, okay, before the worksheet. Okay, if you'd like to work with me through the graphing review and the other notes, try to make your life a little easier with some fill-in-the-blank notes so you don't have to write as much. All right, so here's our graphing review. Okay, there's a lot of different ways to graph functions. I have a preference, okay? Mine is usually to work with slope-intercept form, okay? Remember, this is y equals mx plus b. That is slope, which is rise, ooh, that's illegible, rise over run. And this is your intercept, your y-intercept. Okay? So I like to do it this way, where I just plug in, okay, these values. So I always start my y-intercept. We're going to do this first one in purple because I like purple. All right, y-intercept is positive 6, so I'm going to go up to 6, 1, 2, 3, 4, 5, 6 on the y-axis and put a dot. There's my 6. Really struggling with my handwriting, guys. All right, there's my 6. All right, and then I look at my slope. It is rise 1 and over 3. And I put another dot. Rise 1 over 3. More dots. Rise 1 over 3. I do expect if I give you a coordinate plane like this, okay, to fill it all the way out. I do not expect just a little line. I want the whole thing. So that's what that function looks like. Okay. Now going backwards, I know that this one is rise 1 over 3. That's how I got it backwards. I just worked backwards in my head. All right, get rid of all my stray dots. And some of my line as well, apparently. Whoops. Now, I obviously am not the greatest artiste that's ever lived, so it's okay if your lines are a little wobbly as long as I can read them. All right. Now, another method you can do is making a table, okay? Because sometimes a rise and run isn't as obvious, so let's look at this one. Okay, I've got negative x and negative 4, so I'm going to do this one in green, okay? I'm going to make an in-out table in this one. So what we're putting in, okay, which is my x value, and what's coming out should be a y value, okay? Let's say I want to start with something simple. Let's start with plugging in negative 3. If I plug in negative 3, okay, I'll have negative 3 minus 4. Negative is a positive 3. I get negative 1. Okay, so my in is my x value, so I go over to negative 3, 1, 2, 3, and my output was negative 1. Okay, that's my x and y. So remember, it's x and y. Next, I'll plug in negative 1 and say f of negative 1, negative 1 again, minus 4. Negative 1 is 1. So 1 minus 4 gives me negative 3. So now my input is negative 1, and my output is negative 3. There's my next dot. I can do it with 0. Negative 0 minus 4 is still 0 minus 4, which is negative 4. So at 0, negative 4. Plug in 1. I can plug in any number I wanted. F of 1 is negative 1 minus 4, which is negative 5. Positive 1, negative 5. And as you can see, our dots are starting to form here. Okay, and that is our line. Okay. Other thing you could have done, which I still think is faster, is rise over run and our intercept. Because this is a negative 1x, which means I'm falling 1 and running 1, and I start at negative 4, which you can see works. Here's our negative 4, and we fall 1, run 1, fall 1, run 1. All right, if you're still struggling with graphing, go back and watch the video that is also linked up there, okay? If you're in doubt, plot points until you have enough points to graph the entire line, okay? Flip to the next, well, you don't have to flip, look to the right to the next section, okay? What we're going to do is graphing inverse functions, okay? As you've noticed, functions take inputs, x, and give back outputs. Inverse functions take those outputs and give back the inputs, okay? So the first thing I'm going to do, okay, is I'm going to graph in blue my f of x function. So to do that, I'm going to give myself some help with my table. I'm going to plug in some ins to get some outs. If I plug in 0 of 2 times 0 minus 1, right? Because that's what f of 0 is. Okay, 2 times 0 is 0. 0 minus 1 is negative 1. So my first point will be 0, negative 1. 0, negative 1. Okay. I repeat this procedure by plugging in 1. 2 times 1 minus 1. 2 times 1 is 2. 2 minus 1 is 1. So my next point is the point 1, 1. Again, if you prefer using your slope and your intercept, you'll notice your slope is rise 2, run 1 with a negative 1 intercept. And I'm going to keep going. If I plug in 2, I get 2 parentheses 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. So I go over to 2, 3, plot my dot. And I can keep doing this for as many as I wanted. Okay. Until I had enough that I say, oh wait, I can draw this line now. So we're at 3, 5, counting is hard. All right. And so you can see my f of x function has formed up beautifully here. I am so bad at drawing lines. Okay, and I don't want to just stop. I want to try and continue my line down following that slope I'm seeing. And that's f of x. Oh, wow. Alright, so there's my f of x. So I need to now do my inverse. This one's a little harder to graph by eye, so we're going to go ahead and do our table just like we did before, okay? Now, I'm not necessarily going to choose the same points because I want to do easy math, okay? You can choose any numbers you like. You could be choosing 33, but I tend to keep my numbers pretty small. So if I plug in negative 1, okay, if I plug in negative 1, I'll have negative 1 plus 1 over 2. Okay, what's negative 1 plus 1? That is 0 over 2, which is 0. So that means my first point I'm working with here is negative 1, okay, 0, which is right here. You'll notice I may have chosen this negative 1. Okay, so the next thing I'm going to plug in is 1. I'm using my outputs of my previous function for the inputs of my new one. So if I plug in 1, I'll have 1 plus 1 over 2. What's 1 plus 1? Oh, that's 2. 2 over 2 is 1. So I get 1, 1. Huh, funny how we've already had that point on our normal function. I'm going to plug in 3 next. Wild guess, I'm going to get 2 as my answer. All right? So I'm going to have 3 plus 1 over 2, which is 4 over 2, which is 2. How funny. Okay, so if I plot my 3 and 2, here it is. And again, if I plugged in 5, I'm going to get 3. Okay, and I know that from looking at my regular function. So my inverse function at 5 will be at 3. Who sees a pattern? I hope you see a pattern. All right, so that's my inverse function. Okay, so the pattern, okay, is my t-tables, which is what these are called, are swapped. I can spell swapped. All right, t-tables are swapped. My x's became my y's and my y's became x's, okay? This is because, remember, inverse functions are opposite actions. And if you remember, when we were finding them, the first thing we did was switch x and y. So when we are graphing, it literally switches x and y. This causes a really important thing to happen, okay? It causes our lines to have a reflection. If you remember reflections from geometry. Okay, it reflects over y equals x, okay, our original OG line. So there is a reflection or fold. A lot of you like to think of reflections as folds. Okay, if you did a really good job on graphing and you did it really tidy, you could literally fold your paper and see that these reflected over themselves. Okay, so that is a reflection over y equals x, which is the whole point of inverses. Okay, I'm going to do another. Okay, now this is more like the problems I will be giving you in the future. I will tell you to find the inverse, okay, and then graph it. Okay, so we're going to go through our finding the inverse process. I know I need to change this to y before I can proceed. I know I need to switch my x and y, which is why this whole graphing thing is happening to you. And then I need to solve for y. So that's a little refresher. So I get my inverse function is x minus 2 over 3. Okay, so now I'm going to graph them. Okay, and again, this is on that worksheet on the bottom left. All right. So for my regular one, which I'm going to do in blue, okay, I can choose again any x's that I like. I really tend to like to start to -2, -1, 0, 1. Okay, pick things close to 0, keep it central. All right, so if I plug in -2, okay, 3 times -2, okay, plus 2. Okay, 3 times -2 is -6 plus 2. That gives me -4. Okay, and I can do that for each one, but I'm going to just start doing them in my head. When I plug in -1, I'm going to get -1. When I plug in 0, I will get 2. And when I plug in 1, I will get 5. So I'm going to plot those points. So -2, -4 first. Okay, -1, -1 next. 0, 2 after that. And 1, 5 after that. So there is my original function in blue. Oh my. So very steep little guy. Okay. Now, my inverse function, I could work through a lot of effort, or I could just swap it. All right. You can check me if I'm wrong, but if I make my input -4 from right here, I will get out my -2 I put in. So I'm basically just reversing my previous t-table, which makes life a little easier. Plotting this, you start at -4, -2, -1, -1 happens again. Okay, then we have 2, 0, which is right over here, and then we have 5, 1. Okay, so this is a not steep line. Okay, and that is our inverse function. Okay, here we go. In our original f of x. Try and keep this from being super long, but I'm not exactly succeeding. And again, you can see the beautiful fold that is folding. Okay, now you are going to have a project when you come back to school, and I am going to expect that you know that there's a fold on y equals x, and that you can fold the graphs over themselves. Okay, let's do that last example on the bottom of the page. I downloaded it. All right, so slight struggle in my life, because of course, why not? All right, due to time constraints, we are not going to do that third example. If you'd like to try it and show it to me at some point, that would be wise. Your job now is to use the graph paper I gave you to find the inverse of each function and graph them, okay? The challenge problems, which I would love for you to try, are 13, 14, and 15. If you try those, I will probably give you a prize, but you do not have to if you do not want to. All right? So good luck. Contact me if you need help.